Okay, welcome to our section on electroencephalography, and we're going to start with a little segment about measuring the brain. So this is going to be our only module that deals with the head and the brain. And first thing to be aware of is, again, this is non-invasive. So as you might have studied in other classes, you can do single unit recording where you actually stick a probe inside a person or an animal's brain, touch one little tiny cell in there and record something, and you know exactly when that cell is firing or not. This is non-invasive, so we have to work at the surface of the scalp. And just as a reminder, perhaps from other classes, of what all is happening between the brain and the surface of the scalp. There's a lot. There's a lot of protective material. There's the skull, so there's bone. There's the dura mater. You might remember all the duras. And there's a lot of layers here. Meninges, it goes on. And that is serving to dampen the signal that's coming from the brain itself and that's finally being received with the electrodes that are on the scalp. So keep that in mind as we talk about some of the drawbacks of EEG and how much you can glean from an EEG record. So the two key features that we're going to be looking at for the waveform are the frequency, and this is measured in hertz or cycles per second, how many waveforms are happening in a second. I like to visualize this as how crammed together the waves look, or how spread out they are. So the more crammed together they are, the higher the frequency. The more spread out they are, the lower the frequency. The other key waveform that we're going to be analyzing is amplitude, and that's just the height that the waves reach. So that should be fairly intuitive. It's measured in microvolts. So one electrode at the surface of the scalp is receiving information, electrical activity, from thousands of neurons that are in the brain. And kind of similarly, so 1 square millimeter of cortex, once you've actually gone down through the layers of the brain and found the cortex, which we're not going to do, but imaginarily, 1 square millimeter has 100,000 neurons in it. So you got 100,000 neurons in every millimeter of cortex, and they're sending their signals up to the surface of the scalp, which is then being received by the electrode. So you're kind of doing a lot of aggregation with EEG, and it's something to keep in mind. So therefore, what you might expect, EEG's big disadvantage is the degree of spatial resolution. So that's how precise you can be about where in the brain the signal was coming from when the EEG electrode picked it up. So it's not very precise at all. So over here on this axis is listing different units of measure within the brain, starting with the cell. So we talked about single unit recording, single cell recording. That has fantastic spatial resolution. So this is a little confusing because if it's fantastic, it's low. So that means you can find the most minute degree of detail with this technique of brain measurement, single unit recording. The higher you get, the worse your spatial resolution is. So EEGs, maybe they can tell you differences at the lobe level. So you think about the 4 main lobes that you've studied of the brain. EEG can kind of maybe get you to that level. Maybe it came from the frontal lobe, maybe it came from the parietal lobe, etc. Now, something that EEG is fantastic with is temporal resolution, telling you when something happened. So this, again, where low is good, it gives you the more minute degree of detail that you're looking for. EEG can give you temporal resolution on the order of milliseconds. So it's excellent at temporal resolution. Whereas of things over here, PET scan, etc., you lose a lot of temporal resolution. So if you're really interested in somebody's brain reaction to a stimulus that you just provide them in the moment, these techniques probably wouldn't help you. You need to have you need to be interested in a different kind of answer if you're using these techniques. If you're interested in minute millisecond to millisecond responses in the brain to some sort of stimulus, if you're doing that kind of research, EEG would be excellent, especially if you really don't care about where it came from, you just care that the brain responded in some way. So, excellent temporal resolution, poor spatial resolution.